Good morning. Am I audible to you?
Yes, sir.
Okay. Shall we start?
Yes, we can.
Okay. Now, in my last session, we had a discussion related to correlation. Moving further, today we will be talking about Spearman's rank correlation. Carl Pearson's correlation coefficient has been discussed above. It is not applicable in cases where the direct quantitative measurement of a phenomenon under study is not possible. For example, we can study intelligence, efficiency, performance, competitive events, attitudinal surveys, etc. In such cases, a measure to ascertain the degree of association between the ranks of two variables x and y is called rank correlation. It was developed by Edward Spearman and its coefficient is denoted by capital R. And the formula is R equal to 1 minus 6 sigma d square upon n into n square minus 1, where n is the number of pairs of ranks and summation d square is the square of difference between the ranks of two variables. Now we will discuss this concept with the help of a problem. Is the screen visible to you?
Yes, sir.
Now, this is basically data provided to us. Two judges in a quiz contest rank the 10 competitors in the following order. This order A, B, C, D, these are the competitors, and two judges are there. And they have given their respective ranks. Now, the thing is that we have to find out what is the rank correlation between these two, the observations which are provided by two judges. We will be converting this table into this form. Competitors A, B, C, D, E, F, G, H, I, J. And these are the ranks which were given by Judge 1 and Judge 2. Judge 1 will be marked as R1 and Judge 2 will be marked as R2. We have to keep one thing in mind. The ranks in this particular problem, the ranks are given. We have not determined the ranks. The ranks are given. When the ranks are given, so straight away, we don't have to apply any such procedure. We straight away find difference. D is equal to R1 minus R2. Straight away, we will be subtracting 4 from 6, 1 from 4, 6 from 3, and so on. So we will be getting D as 2, 3, minus 6, minus 3, minus 1 until 3. Then we will be squaring these numbers. So D square, 2 square is 4, 3 square is 9, minus 3 square is 9, minus 6 square is 36, and so on till the last part. Last one is 3 squares is 9. We will just add them up. This sum comes out to be 128. Now, we have the formula of R equal to 1 minus 6 sigma d square upon n into n square minus 1. Here, your d summation d square is 128, your n is 10. After applying it as 1 minus 6 into 128 divided by 10 into 10 square minus 1, On solving, we get 0.22. Here, the rank is positive, so we can say that the conclusions or the observation what the ranks the judges have provided, they have a particular positive correlation between them. So that means that is in the case of the observations. Now we move to unit 16, that is simple linear regression. Now the thing is that what is the concept of regression? In regression analysis, there we have two types of variables. First one is dependent variable and the other one is independent variable. As the name suggests, the dependent variable is explained by the independent variable. In the simplest case of regression analysis, this is there is one dependent variable and one independent variable. Let us assume that consumption expenditure of a household is related to the household income. For example, it may be postulated that as household income increases, your expenditure also increases. Here, consumption expenditure is the dependent variable and the household income is the independent variable. The relationship between X and Y can take many forms. The general practice is to express the relationship in terms of some mathematical equation. The simplest of these equation is the linear equation. This means that the relation between x and y is in the form of a straight line and is termed as linear regression. When the equation represents curve, that means it is not a straight line, then it is called nonlinear or curvilinear. We have to take another decision that is the identification of the dependent and the independent variables. This again depends on the logic put forth and purpose of analysis, whether y depends on x or x depends on y. Thus, there may be two regression equations from the same set of data. These are y is assumed to be dependent variable on x. Then we say that it is, or we can say that it is termed as y on x. And if x is assumed to be dependent on y, then we say x on y line. Now we will see how these lines are obtained. If we consider two variables x and y, we shall have two regression lines, that is regression of y on x and regression of x on y. The first regression line, that is y on x, estimates value of y for a given value of x. Similarly, the second regression line, that is x on y, estimates the value of x for a given value of y. These two regression lines will coincide if correlation between the variable is either perfect positive or perfect negative. Now we see this is a problem which is related to rainfall and agricultural production for 10 years, which is given to you in a tabular form. Now we are what we are doing. We are converting this into a diagrammatic form. Rainfall is taken on x-axis and the agricultural production is taken on along the y-axis. When we plot these lines, that means we will be plotting 60, 30, 60 and 33 on a graph. Then 62 and 37, 65, 38, 71, 42. Similarly, till 90, 57, all these points will be plotted. But once the all points are plotted, we draw a straight line, which should include maximum number of points in a straight line. This is basically, if the line is drawn, that is a regression line. If no line is drawn, then it is a form of a scatter diagram. This is the simplest form from where we can say that there is a perfect positive correlation because the graph is moving from bottom to top, and that too in a straight line. And going back to the tabular form, we can see that when the rainfall is increasing from 60 to 90, the agricultural production in tons is also increasing from 33 to 57. We must therefore establish a criteria for selecting the best line. The criteria used is the least square method. According to the least square method criteria, the best regression line is the one that minimizes the sum of squared vertical distances observed between the points x, y. Now, how this regression equations are generated. Suppose if we talk about regression equation of y on x. So y is equal to a plus bx, where a and b are constant fixed values. A determines the level of the fitted line at y-axis, that is y-intercept, and b determines the slope of the regression line. X represents the value of the independent variable. Now there are different relations, and see what is the relation between these two amongst themselves. If we talk about y is equal to a plus bx, then we have to evaluate y minus y bar is equal to dyx into x minus x bar. Now the question arises how to evaluate byx. Byx is equal to r times sigma y upon sigma x. Sigma y is standard deviation of y and sigma x is standard deviation of x. Now, if standard deviation is not to be calculated, then we can apply another formula which is equal to summation xy minus summation x summation y upon n whole divided by summation x square minus summation x whole square divided by n. Now, if we move towards the other side, that means we are changing the, or we are trying to get the another equation, that is regression equation of x on y. So that will, x and y will be interchanged. So x is equal to a plus by, and the equation will be x minus x bar equal to bxy times y minus y bar. Similarly, bxy is equal to r sigma x upon sigma y is equal to, numerator will remain the same, but there will be a change in denominator. In the place of summation x square, here in this form, we have to write summation y square. Rest everything, and summation y square minus summation y whole square divided by x. That means there will be a change in the denominator only. These are the relations. Now we will see how the problems, regression equation is created or generated. The least square method, because the thing is that where we will be having the value of x, then we can find out the value of y. But we have two constants between these in these equations, that is a and b. For calculating that value of a and b, we use method of least square. In that case, we have to generate two equations. Those equations are summation y is equal to n times of a plus b times summation x. This is the equation 1. And the other equation is summation xy equal to a times summation x plus b times summation x square. These will be two linear equations, and these two equations will be solved by method of elimination, and we will get the value of a and b. Now we will see how all this will be resolved. The problem is, assume that quantity of agricultural production depends on the amount of rainfall and fit a linear regression to the data given. Now here we can see that dependent variable is y, is the quantity of agricultural production, and the independent variable is the amount of rainfall. So we will be generating our equation y equal to a plus bx. We have to find out the normal equation by the method of b square. How that will be done? We will be converting this into this form. Now see to it. This is the information which is given to us. This much is given. First step, summation x, add all these numbers. Second step, summation y, add all these numbers. Now, x square, square it. All these values will be squared. Square this, y is not required because we have to generate y is equal to a plus bx. Then xy, multiply these two numbers. Then y bar, y bar, y bar means p. How many terms are there? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 terms are there. Divide this and evaluate all these values. Then y minus y bar. Now y is this minus this. This comes out to be negative 0.85. We will be generating this. Remember one thing, we have to sum up summation x, summation y, summation x square, summation xy, summation y. Now, after doing this, we will be forming these two equations. Now, we will be replacing, these are the two basic equations, and we will be substituting the values of sigma y, n is known to us, a is not known to us, b is not known to us, summation x we know, summation xy we know, and we don't know the value of a, summation x is known, and this summation x square is known. So straight away, we will put values over here in these two equations. So we will be getting equation number 3 and equation number 4. By the method, as I told you, by the method of elimination, we will be finding out the values of a and b. A is negative 10.73 and b is 0.743. Your equation will be y is equal to a plus bx. You have the value of a, you have the value of b. This is the regression equation. This is the method of how to generate the linear equation. Now, what is the relationship between Mr. Abdul? Please mute yourself.
Sir, please, can you come again with the table?
Sorry,
Sir, the table. Can you come again? I'm left behind.
some other.
There is some table, the one you left now.
You want that I should repeat it?
Can you come again with table, sir? I am left behind.
Already done.
Yeah, the one you done now.
Excuse me, sir. He wants you to repeat it again.
So, again,
Yeah, again, yes, this table.
okay. Column number 1 and column number 2 were given to you. After that, you have to square x and you have to multiply x and y together. Then your column number 3 and column number 4 will be generated. These 4 columns are enough. Sum up sum of y, sum of x square, and sum of xy. This is enough. After calculating these four columns, we have to substitute the value over here. Summation y is equal to na plus b times summation x. And in the second question, this is what you have to remember. Summation xy is equal to a times summation x plus b summation xy. Substitute the value. You will get 450 is equal to 10a plus 750b. And the second equation will be 34,526 is equal to 750a plus 557,294b. You have to eliminate a and b. By the method of elimination, you can solve these equations. And you will get the value of a as negative 10.73 and b equal to 0.743. That means your equation will become as y is equal to minus 10.73 plus 0.743x. Is that clear now?
Yes, sir. It is clear. You can go ahead.
Only four columns are required. Now, what is the relationship between correlation and regression coefficients? The following points about the regression should be noted. The geometric mean of the two regression coefficients, that is Byx and Bxy, gives the coefficient of correlation. That is, R is equal to plus minus under root Byx into Bxy. Both the regression coefficients will always have the same sign. Either both will be plus or both will be negative. The coefficient of correlation will have the same sign as that of the regression coefficient. If both are positive, R will be positive. If both are negative, your R will be negative. Regression coefficients are independent of change of origin, but not of the state. These are the properties of which you have to remember, and the relation between regression coefficients and regression correlation coefficient. Your correlation coefficient is R, and your regression coefficients are Bxy and Byx. Now, what is the difference between correlation and regression? Correlation, as the name says, it determines the interconnection or a correlation between the two variables. In correlation, both the independent and dependent variables have no difference. Correlation stimulates the degree to which both variables can move together, and correlation helps to constitute the connection between the two variables. Whereas in regression, regression explains how an independent variable is numerically associated with the dependent variable. In regression, Both the dependent and the independent variables are different. Regression specifies the effect of the change in the unit and is known as known variable on the evaluated variable. Regression helps in estimating a variable value based on another given value. This is the most important part, the difference between correlation and regression. Now comes your index number there. Please remember here the different formulas will be there. What is the meaning and concept of index number? An index number may be defined as a special average which helps in comparison of the level of magnitude of a group of related variables under two or more situations. Index numbers are the series of numbers devised to measure changes over a specified time period. That is, time period may be daily, weekly, monthly, yearly, or any other regular time period, or compare with the references to one variable or a group of related variables. Thus, each number in a series of specified index number is a pure number. It does not have any unit, calculated according to a predetermined formula, generated at regular time period intervals, sometimes during the same time interval at different places, and the regular generation of numbers from a chronological order. What are the characteristics of index number? The main characteristics of the measurement of index numbers is it is a relative measurement, it has specialized average, measurement of changes not capable of direct measurement, measurement of common characteristics of a group of items. It is a comparison on the basis of time or place. It is expressed in percentage and it has a universal rule. Relative measurement. Index numbers are measured for comparing relative change in a variable or group of variables at different point of time or place. Specialized averages. Index number is a special type of average that provides a measurement of relative changes in a variable or group of variables. Measurement of changes not capable of direct measurement. With the help of index number, we can measure the changes in magnitude which are not capable of direct measurement due to their complex nature. Fourth one is measurement of common characteristics or a group of items. Index number expresses the common characteristics of a group of items. Change in index does not always mean that there is a change in all variables or variable. For example, an increase in price index does not mean that price of all the commodities increased. Comparison on the basis of time or place. Index numbers is used to measure the relative changes either on the basis of time or on the basis of place. For example, production of wheat in Uttar Pradesh for two different periods or production of wheat in Uttar Pradesh and Haryana in the same period. Expressed in percentage. Index numbers are expressed in percentage to show the relative changes through the sign of percent. and it is never used. Universal use, the technique of index number is being used extensively in all the fields nowadays, be it changes in production, trade, etc. What is the use of how these index numbers are used? Though originally the index number was developed for measuring the effect of change in prices, today they are becoming indispensable for analyzing the data related to business and economic activities. This statistical tool can be used in several ways, such as decision makers use index number as a part of intermediate computation to understand other information better. Nominal income can be transformed into real income. Similarly, nominal sales into real sales and so on. So, an appropriate through an appropriate index number. Consumer Price Index, it is also known as Living Index, is arrived at a specified group of consumers in respect of price of specific commodities and services which they usually purchase. This index serves as an indicator of real wages of the consumers. Different types of price indexes are used for wage and salary negotiation, for compensating in price rise in the form of DA, that is, dearness allowance. Various indices are useful to the government in framing policies. Some of these include taxation policies, wages and salary policies, economic policies, custom and tariffs policies, etc. Index number can also be used to compare cost of living index across different cities or regions for the purpose of making adjustment in house rent allowance, city compensatory allowance, or some other special allowance. Indices of industrial production, agricultural production, business activity, exports and imports are useful for comparison across different places and is also useful in framing industry policies, import export policies, etc. Issues in construction of index number. There are three major issues which may be faced in the construction of index number. They are: first one, collection of data; second one is selection of base year; and the third one is selection of appropriate index. If we talk about collection of data, data collection through a sample method is one of the issues in the construction of index number. The data has to be reliable, adequate, accurate, comparable, and representative as possible. Here, a large number of questions need to be answered. The answer ultimately depends on the purpose and individual judgment. For example, one needs to decide the following: identification of commodities to be included. Second one is source of data. From where to collect data? It is an important and difficult issue. The source depends on the information required. For example, one may need to collect prices and quantities assumed, consumed related to certain commodity for a consumer price index. However, there may be large number of retailers and wholesalers selling the same commodity and quoting different prices. Then comes timing of data collection. It is also equally important to collect the data at an appropriate time. Referring to the example of consumer price index, the prices are likely to vary on different days of the month. For certain commodities, prices may vary at different times on the same day. Take an example of vegetable prices are usually high in the morning when fresh vegetables arrive, and it is low in the late evening when sellers are closing for the day and wish to clear the perishable stock. Then selection of base year. A base period is the reference period for comparing the analyzing the changes in prices or commodity quantity in a good given period. For many index numbers series, value of a particular time period, usually in year, is taken as reference period, against which all subsequent index numbers in the series are collected and compared. The third one is selection of appropriate index. Now, through which there are different methods, which method to be selected. Different methods of indices give different results when applied on the same data. Utmost care has to be taken in selection of a formula which is the most suitable for the purpose, whether to use an unweighted or weighted index. It is difficult question to answer. It depends on the purpose for which the index number is required to be used. How what are the different classifications of index number? They are classified into three types. First one is price index, second one is the quantity index, and the third one is value index. If we talk about price index, this type of indices is the most commonly used or most frequently used. Price indices consider prices of a commodity or a group of commodities and compare changes of price from one period to another period, and also compare the difference in price from one place to another. For example, the familiar consumer price index measuring overall price changes of consumer commodities and services is used to define the cost of living. Quantity indices. The major focus of consideration and comparison in these indices are the quantities either of a single commodity or a group of commodities. For example, the focus may be to understand the changes in the quantity of paddy production in India over different time periods. For this purpose, a single commodities quantity index will have to be considered. Third one is value indices. Value indices actually measures the combined effect of price and quantity changes. For many situations, either a price index or quantity index may not be enough for the purpose of the computation or comparison. For example, an index may be needed to compare cost of living for a specific group of persons in a city or a region. Here, comparison of expenditure of a typical family of the group is more relevant, since this involves comparing expenditure. It is the value index which will have to be considered. These indices are useful in production decisions because it avoids the effect of inflation. Now remember the relation. Summation Q1 P1 upon summation P naught Q naught or Q naught P naught into 100. What are the methods of constructing index numbers? Different formulas have been evolved or introduced by statisticians for constructing composite index numbers. This may be categorized with two broad groups given together, that is, weighted indices and unweighted indices, where the simple income section of indices numbers are P naught and P1. P naught denotes the price per unit of a commodity for the base period, and P1 is the for the current period. Similarly, we have Q naught, Q1, V naught, P1. Capital letter PQV are used for denoting price index, quantity index, and value index. Unweighted index number. This type of indices are also referred to as simple index number. In this method of construction, indices weights are not expressed assigned. They are further classified into two categories. The first one is simple aggregate index, and the second one is simple average of relative index. Now, what is the difference between these? If we apply simple aggress- aggregative index, this is the simplest and the least satisfactory method of constructing indices. In the case of price indices, through this method, the total of the unit cost of each commodity in the current year is divided to the total of unit cost of the same consequently in the base year, and the interest is and the quotient is multiplied by 100. Symbolically, if we talk about terms of price, P01 is equal to summation P1 upon P0 into 100. And for quantity, that will be Q01 is equal to sigma Q1 upon sigma Q0 into 100. Now, we have a problem here by considering the hypothetical data for the year 1990 and 2000. The following computations were done for construction of price index and quantity index. Now you can see that we have 2 years, 1990. The other one is 2000. Items are wheat, clothing, gas, electricity, housing. And the price and commodity for the year 1990 are given in the two columns over here. And similarly for the year 2000, these two are given. First step, add all these. You have to calculate the summation of these all values. This value and this value. Now, how to proceed? The price index for the year 2000 with the reference of base year 1990. The simple regressive method is P naught 01 is equal to summation P1 upon summation P naught into 100. We have P1 equal to 2271 and P naught as 1450.8. After dividing, we get negative 156.5. Thus, we can say the price in respect of commodities considered in the index have shown an increase of 56.54% in the year 2000, corresponding to the year 1900. So this is how the evaluation is done. Now, this method suffices in the following two limitations. The unit size affects the index number. For instance, in the above illustrations, if price of wheat was quoted in terms of kg per kg, rupees 7 is 1990, and for rupees 9.5 it is 2000. Relative importance of different commodities is not affected in the index. For example, in the above illustrations told a total of rupees 2800 is spent on wheat, which is the most important an item of the expenditure. This is not reflected in this method. Now, moving from price to quantity, this becomes Q01, which is equal to summation Q1 upon summation Q0 into 100. Here is the problem, same problem. Now we are calculating quantity. Here we see that summation Q0 upon summation Q. Summation Q1 divided by summation Q0 into 100. After placing of the value, we get 124.64. That means there is an increase of approximately 24%. Limitation: the units of quantities being different cannot be added and the quantities do not represent appropriate values for the purpose of comparing expenditure. Here you can see that if we talk in terms of quantity, so for wheat it is 4 quintals, clothing is in meters, gas cylinder is in numbers. So we can say that it's very difficult to add keeping all the values into consideration. Then comes simple average of relative index. In this method of constructing price index, first of all, price relative have to be computed for different items included in the index. Then the average of these is calculated symbolically. That is summation P0 P01 is equal to summation P1 upon P0 into 100 divided by total number of items. Here you can see we have to generate simple average of price relative. Wheat, clothing, gas, electricity, quantities, and the price of the year is given. So we have to calculate individually for every commodity. You can see P0, P1 upon P0. That is 950 divided by 700 into 100, which comes out to be 135.5. You have to remember the basic formula. And in the relation, you have to know how many commodities are there. What is the number of commodities? Commodities are 5. Therefore, n will be 5. P1 by P0 is being calculated individually and then a total sum is evaluated. In that case, we get 763.9 and your n is 5. That means 763.9 will be divided by 5. It comes out to be 152.78. That means the index of simple average of price relative shows 52.78% increase in the process. Because in this part there are different formulas, but calculation is simple. Either you have to add or multiply. For construction of quantity index, again this will be replaced by Q0, Q01 in is equal to summation of Q1 upon Q0 into 100 divided by n. Now weighted index number. In the weighted index method, weights are expressed assigned to each item which is included in an index concept. The weighting allows us to consider more information than just the degree of change in price or commodity over time. The problem only is to decide how much weight to consider for each of the items included in the sample. This is further divided into two methods. First method is weighted aggregate index, and the second one is weighted average relative index. Now, actual index number starts here. Weighted aggregative index. In this group, we shall study three specific methods commonly used in business research. They are list price index, purchase index, and Fisher index. After understanding the concept of the three indices, we will take up an illustration for construction of these indices. Now, first of all, we will see what this list price indices is. In this method, weights assigned to each commodity are the quantities consumed in the base year for price indices. For quantity index weight used are the price of the commodities in the base year. Then according to Lespes, here comes the formula. See the method of writing it. PLA 201 is equal to summation P1 Q naught upon P naught Q naught into 100. That is for the price. And for the commodity, same thing will change. P will be replaced by Q. It is noted that the method is most popular for constructing consumer price index. It is therefore considered as an aggregative expenditure method, which is one of the methods for constructing consumer price index. Then the second method is purchase index. Now you have to remember one thing, how the things are interchangeable. Both the relations are written in front of you. Here, purchase PA 01 is equal to summation P1 Q1 divided by P naught Q1 into 100. And if we talk in terms of quantity, then Q1 P1 divided by Q naught P1 into 100. Then come what is the comparison between Bastian's and Laspers indices. From the practical point of view, Laspers indexes is usually referred over Bastian's index. This is because as long as the period is fixed, the weights and unit assigned will remain unchanged. Therefore, calculations and comparisons are easier. On the other hand, weight in Pastian formula continues to change with the change in the current year. So that the price index for every year has to be computed fresh interest rates. Then comes your third one, that is Fisher index, ideal index. Now here see, that is multiplication of price index under root summation P1 Q naught upon summation P naught Q naught into summation P1 Q1 upon summation P naught Q naught. Whole outside the square root, you have to multiply it by 100. Similarly, we can modify quantity index plus Fisher ideal index of price quantities under root of product of Laspers index and Patches index. Fisher index is superior because it uses geometric mean of Laspers and Patches indices. Also because it is comparatively free from the tails of overstation and overestimation. Fisher index satisfies the requirement of more universal tests and factors reversal method. The indices is therefore called ideal index. Now we will see for this data price for 2011, quantity 2011, and price 2018 and quantity 2018 is given to us. Now we have to construct index number of prices of items in the year 2018. Index form number from the following data. Data is given to you. This is the modification which is done. We were given A and B. A and B, that was P naught and Q naught was given to us. Similarly, we will find P1, Q1. Then, according to the usage of the formula, we have to identify or calculate P naught, Q naught divided by the second column is P naught, Q1. The next one is P1, Q naught. The last one is P1, Q1. These all values have to be multiplied. Normal multiplication has to be done. And the last four columns have to be added because these all four values will be used in the formula. So we have sigma P naught Q naught equal to 700, sigma P naught Q1 is equal to 1450, sigma P1 Q naught 455, and sigma P1 Q1 as 980. When we calculate Lashpace method, we get 65%. When we calculate with Pastier's formula, we get 67.78. For Fisher's method, we get 66.27. That means the value is revolving around three methods. That is 66.27, 67.59, and 65. Almost we can say that there is a normal relation. Test for index number. The perfect index number which measures the change in the level of phenomena from a specific period to another period should satisfy certain tests. In the section, we describe the two tests as time reversal test and number two is factor reversal. As far as time reversal fact is concerned, if we observe the construction of index number, we found that there are two aspects. They are period and the quantity. However, if we reverse the time subscript such that base period O and current period 1 as a price or quantity index, the result should be the reciprocal of the original index number. Now we will see how. Here we can see this. I'll just numerically, if it is expressed in P01 into P02, 10, the product reversal test. Irving Fisher suggests that one more test, that is Fisher reversal test, to apply to the weighted index to verify the validity. According to him, just as our formula should permit the interchange of the two times without giving inconsistent result, so it ought to permit interchange. The price is P and quantity is Q without giving inconsistent results. That is, the two results multiplied together should give the true ratio. Now we will see how. This is the relation P01 into Q10, which is equal to summation Pi Ui divided by summation P naught Q naught. Now you see how this relation at the right is derived. We are given with hmm, this is the problem. Now we will show that Fisher ideal index satisfies the time reversal test and factor reversal test. This is the problem which is given to us. We are given the price of 2005 and 2018. And similarly, the quantities, that is number of units for 2005 and 2018 is given. The base year will be 5. That means that will be P0 and P1. Similarly, Q0 and Q1. Now, we have to calculate P0 Q0, P1 Q0, P0 Q1, and P1 Q1. All possible flow conditions have to be evaluated. Now, in the right side of your screen, you can see there are three relations or two relations. Basically, P01 F Fisher formula is there. Put up the values, and for P10, again the formula is there. Put up the values. And now bring all these because you have to multiply both P01 and P10. You will get answer as 1 because everything will be cancelled. If we talk in terms of factor reversal test, here what will be the ratio? Since the formula has been changed with Q has been changed with P, so we will go to the original problem. That is, first of all, we have to calculate price ratio, then we have to calculate quantity ratio, and then we have to multiply both, which is equal to 1880 divided by 1360, which is your net value ratio. Consumer price index. This is a method which is known as CPI, and CPI is cost of living index number. This number is to serve as a measure of change in the prices of goods and services commonly consumed by the homogeneous section of people, such as the classes lower, upper, middle, industrial workers, urban and rural, etc. These indices are helpful in deciding DMS allowances, wages, salaries, negotiations, framing price, policy, taxation policy, other economic and welfare policies. The common method for selecting from the consumption basket is to conduct a family living style survey among the population group sections, for which the consumer price index is to be consumed. Prices of selected commonly consumed items are also collected from various retail markets used for such consumers and also the quantity of consumption, normally expressed in terms of weight. The overall price index is computed as a weighted average of group indices and the weighted weight being again the proportional expenditure on different groups. That means we will be calculating CPI as summation W times P1 upon P0 into 100 whole divided by summation of W, where your W is P0 Q0 upon summation P0 Q0, which is the weight of the group index. Now we move to unit 18, that is time series analysis. What is the definition of time series analysis? A time series consists of statistical data which are collected, recorded over successive increments. When quantitative data are arranged in order of their occurrence, the resulting statistical series is called the time series. The analysis of time series is of great utility not only to research workers but also to economists, businessmen, and scientists, etc., for the following reasons. It helps in understanding past behavior of the variables under the study. Number two, it facilitates in forecasting the future behavior with the help of changes that have taken place in the past. Number three, it helps in planning future course of action. Number four, it helps in knowing current accomplishment. And it is helpful to make comparisons between different time series and significant conclusions can be drawn. Thus, we can say that the need for time series analysis arises because we want to understand the behavior of variables under the study. Secondly, we want to know the expected quantitative changes in the variable under study. And we want to estimate the effect of various causes in quantitative terms. Now, question is, what are the components of time series? The causes which affect the variables gradually and permanently are termed as long-term causes. The example of such causes are increase in the rate of capital formation, technological innovations, the introduction of automation, changes in productivity, improved marketing, etc. Though there are many. The effect of long-term causes is reflected in the tendency of a behavior to move in an upward or downward direction, which is termed as trend or secular trend. It reveals as to how that time series has behaved over the period under study. The causes which affect the variables for the long time being only are labeled as short-term causes. The short-term causes are further divided into two parts, and they are regular and irregular. Regular causes are further divided into two parts, that is cyclical and seasonal causes. The cyclical variations are also termed as business cycle fluctuations, as they have influence on the variable. A business cycle is composed of prosperity, recession, dep- depression, and recovery. The periodic movement from prosperity of recovery and back again to prosperity vary both in time and intensity. The seasonal causes like weather conditions, business climate, and even local customs and ceremonies together play an important role in giving rise to seasonal movements to almost all the business activities. For instance, the yearly weather conditions directly affect the agricultural production and farming. It is worthwhile to say that the seasonal variation analysis will be possible only if the seasonal data are available. This fact may be checked first. For analyzing the seasonal effect, various methods are available. Among them, seasonal index by ratio to moving average method is the most widely used. However, if the collected data provides only yearly values, there is no possibility of obtaining seasonal variations. Therefore, the residual amount after eliminating trend will be the effect or irregular or random causes. Irregular causes are also termed as erratic or random causes. Random Variations are caused by frequent occurrences such as wars, strikes, earthquakes, floods, etc. These reasons either go very deep towards downwards or very high upwards. Long-term causes are secular trend or trend that is denoted by T. Short-term causes are regular, they are cyclical denoted by C, seasonal denoted by S, and irregular or random or erratic denoted by I. We will be finding out a relation between the four components. Then decomposition of time series. Decomposition and analysis of time series are one and the same. The original data or observed data, that is O, is the result of the effects generated by the long term and short term, namely trend, cyclical, seasonal, and irregular. Finding out the values for each of the components is called decomposition of a time series. Decomposition is done either by the additive model or the multiplicative model of analysis. That means additive, we will be adding all these four values, and for multiplicative, we will be multiplying all these four values. Which of these two methods is to be used in analysis of time series depends on the assumption what we might make about the nature and relationship among the four components. Additive model, as I said, all the four will be added. And in multiplicative model, all the four will be multiplied. Preliminary adjustments. Now, since the data has been of procured, we have to consider different adjustments if they are required. Now the question arises, what are the different adjustments are? Before we proceed with the task of analyzing a time series data, it is necessary to do relevant adjustments in the raw data. First one is calendar variation. As we are aware, all the calendar months do not have the same number of days. For instance, all production in the month of February may be less than other months because of favor days. And if we take the holiday into account, the variation is greater. Therefore, adjustments for calendar variations have to be made. Second one is price changes. As price level changes are irreversible, it is necessary to convert monetary values into real values after taking into consideration the price index. The third one is population change. Population grown constant. This also calls for adjustment in the data of the population changes. In such cases, if necessary, per capita value may be computed, dividing original figures by total population. What are the methods of measurement of trend? The effect of long-term causes is seen in the trend value we compute. A trend is also known as secular trend or long-term trend as well. There are several methods of isolating the trend, of which we shall discuss only two methods which are frequently used in the business and economic time series data analysis, and they are moving average method and method of least square. Now we will see. If we will start with moving average method. Moving average method is an arithmetic average of data arising over a period of time and is calculated by replacing the first item in the average by newly arising item. Each moving average is based on values covering a fixed time span, which is called period of moving average. Now we will see how this computation takes place. We have the yearly values. If we take 3 years moving average, that means we will be computing A plus B plus C, then B plus C plus D, then C plus D plus E, and then D plus E plus F. And 3 years moving average will be divided by all these four values divided by 3. We have either an odd period of moving average, that is 3 years, 5 years, 7 years, or an even period of moving average, that is 2 years, 4 years, 6 years. The period of moving average is generally determined in the light of the length of the cycle in the data. Ordinarily, moving average period ranges from 3 to 10 years for business. So what we will be doing? We will be taking into consideration 3 years. 15 plus 25 plus 32, which comes out to be 72. It will be written in the center line. Then 25 plus 32 plus 24, that it comes out to 81. Then next three and the last three. For 5 years, we will be adding five values and we will be dividing by five. You should note that moving average for the first 3 years, 2001 to 3, is 72. Associated with the, this is the method how it has to be written. Having dropped the first year, we will come down. Even period of moving average. If the period of moving average is even, so either 4, 6, or 8, the moving average total and moving average would not coincide with the original time period. It would not be possible to place moving average exactly against the same year. Therefore, you have to resort to centering, and centering is done in a manner that helps coincide the moving average with the original data. But this is the data given to us. How many years are there? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 years. Now see how this is formulated. We are talking about 4 years moving average. So we will be adding 75 plus 60 plus 54 and 69, and we will be writing on the third row. For 4 year moving average, we have to divide this number by 4. And for centering, we will be adding and dividing by 4. You can check it, leaving 75 now at 60, 54, 69, 86. Then in the next, leave 50, leave first two, 54, 69, 86, 65. 69, 86, 65, 63. You will come down, and this is how 4 years moving average table is computed. Here you can see how it is made. The total 258 of the first four and the average of is 64.20 is written against the middle of the time period. Now if we see like this, for the 4 years, 97, 98, 99, 2000. If we add, now you can see how these values have been obtained. If we talk about least square method, this is also known as straight line method. You have seen it in regression. This method is most commonly used in research to estimate the trend of time series data. It is mathematically designed to satisfy two conditions. Again, two conditions are there. Sum of y plus yc is equal to 0 and sum of y plus yc's whole square is least. As we know, again, these two equations are there, you are aware of it, which we have used in regression analysis. Summation y is equal to na plus 3 times summation x, and the second equation is summation xy is equal to a times summation x plus b times summation x. If the data is very simple, so then in that case you can apply the formula directly. For A, it is summation y upon n, and for B, it is summation xy upon summation x square. You have to remember the formula. That's it. That is the most important part. Now let us see how to solve this. This is the data given to us. The formulas are here. Now how the calculation is done. Now see, year was given and sales was given. You have assumed the center one as year 2001. In place of that, we will straight away write 0, above it minus 1, minus 2, minus 3, and below 0, 1, 2, 3. Then we will be squaring it, x square. Then we will be multiplying x and y. X and y means multiplying 70 and minus 3. That will be minus 210. Now the question arises from this data how you will calculate the value of A and B. Now A is summation y upon n, your summation y is 609. 609 divided by 7 is 87. And for B, you have to evaluate summation xy upon summation x square. The summation xy is 117 and your summation x square is 28. So 117 divided by 28 is 4.18. Yes, dx. That is the trend equation. That is the trend equation for this data. What was the last year given? Now you can see in this by the help of this equation, by the help of this equation, we will be calculating the sales in tons for year of 2006, which is after this. So see how you will get the value for 2006. What is the change in the equation? 1, 2, 3, 4, 5. For 2004, 2005 it will be 4, and for 2006 it will be 5. What we are doing? 87 plus 4.15 into 5, which comes out to be 1.79 thousand tons. Similarly, for 2008, we will be adding 2 more to this. 5 plus 2 is 7. Straight away multiply, you will get the value. And if you want to evaluate before this, 1997, so what we will be doing? We will be replacing this x by minus 3. Here it is. This is Cramer's rule. Let me see to it what is required. Okay, just a brief of how to calculate mean for a group data. I'm just recalling some of the numerical part now because the theory part has been completed. If you have pen and paper with you, you can write it or you can calculate it of your own. I'm showing you different slides which are having numerical component so that it will be easy for you to understand it. If you have any problem in understanding, please let me know. We have to calculate mean for the group data. These two columns are given to us. We have calculated the mid value. I'm just recalling a brief how this mid value is calculated. Mid value is calculated by adding 140 and 150, which comes out to be 290, and dividing it by 2, which comes out to be 145. Since the difference is of 10, so we will be adding 10. We won't be doing it again and again for each observation. 145, 155, 165, 175, 185, and then multiplying these two. You will get this and dividing this by 25. This is how the mean is calculated. Ha! This is much more important and to understand how the median is calculated. These two columns will be given to you. You have to generate a column for cumulative frequency. Now the question arises how this cumulative frequency is obtained. Write 1 in front of this one. Then add this 4 to this one. You will get 5. Add 8 to this 5. You will get 30. Add 7 to it, you will get 20. And add 5 to it, you will get 25. Keep one thing in mind, this 25 and the sum over here will always be same. The sum over here and the number over here will always be same. Now we have to calculate median, so we have to calculate n by 2. N by 2 means 25 by 2, and 25 by 2 means 12.5. Now you have to go to this cumulative frequency table, find out that class where 12.5 lies. There are two ways where 12.5 is there and a number greater than 12.5. So we can see that a number greater than 12.5 is 30. So we will mark an arrow over here, and this will be the class of our study. Now the formula is L plus n by 2 minus Cf upon F into I. Your L is this 160, lower limit. N by 2 is 12.5. Cf is the cumulative frequency above the median class. You have chosen this as the median class. This 5 will be the Cf. And the frequency of the median class. Frequency of the median class, that is 8. Place of the values, and your I is 10. The difference between this comes out to be your median, 169.375. This is the mode. For identification of the model class, you have to consider the highest frequency in the table. Here you can see that highest frequency is 8. So your model class will be 160 to 170. That means your L MO will be 160. Now the question according to the formula. The frequency or the class which is having the maximum frequency. In that frequency you write FM. Frequency above it will be marked as FM minus 1 and the frequency below it will be marked as FM plus 1. Referring to the formula, place up all the values and you will get the mode. This mode is for the group data. Now we have an empirical relation for calculating mode. If we have in a problem, if mode has to be calculated and we are aware of about the mean and median. So there is an empirical relation between mean, mode and median. That is mean minus mode is equal to 3 times of mean minus median. So after evaluating it, we get a relation as mode equal to 3 times of median minus 2 times of mean. After evaluation, you will get 56,000, 5600, 5614.88. Now comes where with measure of variation and skewness. You have to calculate the quartile deviation and its coefficient. Okay. For quartile deviations, you have to calculate cumulative frequency. There comes the cumulative frequency. And for quartile deviation, if you remember, you have to evaluate Q1 and Q. Your n is 60, so n by 4 will be 15. Second column, second row. And for Q3, that will be 45. That will be 55 to 60. Take away place of the formula values. A quartile deviation will be Q3 minus Q1 divided by 2, and the quartile deviation coefficient of quartile deviation will be Q3 minus Q1 upon Q3 plus Q1. This all we have already done. I'm just showing you how the problem will be there and what are how the calculation has to be done. This is the weight of a calf at weekly interval is given to you. You have to fit a line to the above data and then give an estimate of the weight for the calf when it is 7 weeks old. The data for 5 years is given and you are being asked to calculate it for the seventh week. Now the thing is that straight line is being asked, so we will solve through least square mean method. Your line is y is equal to a plus bx. We have two equations. This is given to us. This is given to us. So we will solve this. Okay. And these are the two lines. Substitute the value and by the method of elimination, we will evaluate A and B. Lace up with this and we have to calculate the value of y when x is 7. Replace this x by 7. You will get 53.4. That means with the passage of time, the weight is increasing. This is again a straight line. So to fit a straight line, we will be using again this formula. When we have to fit up a straight line, this is the only option what we have. Now the ranks. This we have done today. This is for the limits. If a problem is given to you and it has under roots, and when you apply limit x tends to 0 to it and it becomes 0, you have to rationalize it. And the rationalization is done by the opposite sign of what is given over here. Here you can see it is minus. So we will be rationalizing this with the opposite sign. On the right hand side, there is a problem where limit is it states that limit x tends to infinity. In that these types of problem, you have to divide numerator and denominator by the maximum power. Here maximum power is 3. So that means you will be dividing numerator and denominator by x power 3. So see, after dividing, this will be generated, and when the limit will be applied, everything will be 0 because your numerator will be 0. Numerator will be 0 due to this reason. This is 2 by x. Now we have to calculate local maxima and minima of the function. First of all, we have to find the first derivative. Equate that first derivative to 0. You will get here, you will get two values, 2 and 3. Find out select any value of x less than 2 and see the sign of the resultant. Here in this you will get plus, and any number between 2 and 3. So here you will get negative, and any number greater than 3 you will get positive. That means in two regions it is increasing and it is having a maxima, and then oh, there is a change of sign from plus to minus. As x increases through 2, x is equal to 2 is the point of local maximum, and x is equal to 3 is the point of local minimum. Okay, this is the cost of the firm. Cx is equal to 0.005 x cube minus 0.002 x square minus 30x plus 5,000. This is the cost one. Now from this, you have to evaluate fixed cost, variable cost, average cost, average variable cost, marginal cost. 9 parts or 9 answers have to be answered from this. Here you can see. The cost function is this. Fixed price will be putting x is equal to 0. You will get fixed price as 5,000. Variable cost, total cost minus fixed cost. That means 0.005 x cube minus 0.002 x square minus 30x. This is the variable cost. Average cost is total cost divided by x. Average variable cost is variable cost divided by x. Marginal cost is derivative of total cost. When x is equal to 50, okay, that has been calculated from here. Marginal cost when x is equal to 50 are produced, interpreted the result. Here what we will be doing, when we will be calculating marginal cost as 50, we get 7.3. That means, it means if production increased by 1 unit from 50th unit to 51 unit, the total cost increases by 7.3 rupees. Then what will be the cost of the 51st item? It will be substitute the value of 51 in the total cost function. You will get 4,128.05. After calculating C50 and C51 and subtracting from it, you will find the actual cost of producing the 51st unit, that is 8.05. What is the rate of change in marginal cost? Marginal rate of change of marginal cost is differentiating marginal cost once. And marginal average cost is average derivative of average cost. Okay, this is related to your compounding. Bank pays compound interest at a rate of 5% per annum. Yogi deposited a principal amount of 5,000 in a bank for 4 years. Find the interest Yogi will get. In compound interest, remember that you always get interest. So you always get amount. Amount is equal to P into 1 plus R raised to the power n. Your principal is 5,000. Your rate of interest is 5%. That means 5 upon 100, which comes out to be 0.05. And your time period is for 4 years. That means your n is 4. Place up the values, calculate the value, multiply it. When you multiply it, that means your amount comes out to be 6,077.53. What was your principal? That was 5,000. Subtract it. That means your interest is 1,077.53 rupees for 4 years. Now, any question from anyone?
No question, sir.
Anyone? No questions. Others, please. Because today, yeah, what do you want to say, Mr. Abdul?
Sir, no question, I said.
I can't hear you. Can you write it in the message box?
Okay, sir. I said no question.
No questions. Okay. Because as far as our schedule is concerned, today it is our last session, and I had completed part A and part B both of your BCOC 134, and I hope you would have you enjoyed and you have learned. With this, I will be concluding today's session, and all the best for your future.
Thank you,
Well done,
sir.
sir. Well
Thank you,
done.
sir.
Bye. Bye, sir. Hello, Anita.
Yes.
Hey, the thing I want to tell you is I submitted my assignment back to Unakapo.
How? I'm failing to submit.
What are you saying? You're saying something?
Those are we are
Uh,
discussing